Obtain the mesh file and also the full training movie by purchasing this product.
In this project, we will simulate internal airflow inside an atrium building. This project simulates the internal airflow inside an atrium located in a complex. The story of atrium originates from the architecture of ancient Roman houses, and its modern models in recent centuries are multi-story and have a glass roof and a set of windows that are usually located immediately after the main entrance of the building. This part of the building is used to provide the necessary light for the interior of the building as well as building ventilation. Atrium works with two natural phenomena, including the greenhouse effect and chimney effect. The present model is drawn in 3 dimensions using design modeler software. The model consists of a building area of a large complex with a cylindrical space called atrium inside it. The meshing of this model has been done using ANSYS meshing software. The mesh type is unstructured and total element number is equal to 2,496,105. The cells adjacent to the internal boundaries are smaller and more accurate. By clicking on the check button, you will see that in the Console tab, the Fluent software will start to check your mesh for any errors. There are several assumptions made in this project. The first one is that the type of our solver is set to be pressure-based, since we are dealing with incompressible flows. The second one is the velocity formulation is taken to be in the absolute form. And as for the time, we have taken the steady simulation process, since we don't want our results to be a function of time. Also, the gravity is ignored in this project. In the appeared window, you can see the velocity magnitude for its boundary is defined to be 2 meters per second. Also, the type of boundaries for outlet is defined to be pressure outlet. And again, by clicking on Edit, we will be able to change the settings for this boundary. There are two ways to check that your simulation process have reached convergence. Alongside the checking the residuals or reaching and nearing the zero, you may define some report to make sure that an equation have reached convergence. For example, by just right-clicking on the report definition, going on the new, you are able to choose between different reports. For example, you can define a mass flow rate report on a arbitrary boundary based on your geometry and your simulation. You are able to see whether this mass flow has reached a constant value or not. If yes, it may be a sign that your simulation has reached convergence, but the residual must be checked as well. Contours of pressure, velocity, velocity vectors, and streamlines are presented to you using CFD post software. After clicking on location and then selecting plane, a new window will appear. In the appear window, under the definition section in front of the method, we click on ZX plane and then set the value of y to the defined value. And then we apply to create a new plane. As can be seen in this pressure contour, the atrium has clearly a higher pressure than the other spaces, which causes the air to spread in those rooms and spaces and to ventilate the air in those areas. In velocity contour, as was mentioned in the previous slides about the pressure contour, you can easily see the air velocity moving inside the spaces. Now, in order to see the streamlines inside the computational domain, you just have to click on the streamlines and then accept the appear window. After that, in the details of streamline, you just have to change the type of streamlines to surface streamlines, and under the definition section, you just have to select the plane that we have created before, and then click on apply to show the streamlines for you. As was mentioned before in previous slide, you can easily see the streamlines of air flow moving inside the spaces of this building. Now, in order to create a 3D contour, you just have to click on volume rendering button and accept the appeared window. And then under the detail of volume rendering, you just have to select the variable you desire. For example, in this slide, we selected pressure and then click on apply to show the 3D contour to you. Finally, a summary of different settings and setup that we have used in our project is presented to you in the slide.
Obtain the mesh file and also the full training movie by purchasing this product.
To benefit from Mr. CFD services including simulation, consultation, and training, contact our experts via info@mrcfd.com.